Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in finding the maximum path sum in a binary tree. First, let us take an example. In this binary tree, the maximum path sum will be between nodes 20 and 10, which is 42. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node to find max function, so root will point to 10. We take a res variable and initialize it to int min. Now we call the findMaxUtil function with root and res. Since root is not null, we take L and R variables to store maximum path sum going through left and right child of root. So we pass the left child of root, which is 8, using a call stack. Again, as root is not null, we pass the left child of 8, which is 3. Again, as root is not null, we further pass the left child of 3, which is null. So root will point to null. As root is pointing to null, we return 0 and resume execution for node 3. Now we pass the right child of 3, which is also null. Again, as root is pointing to null, we return 0. Now we take a max single variable and it will store the max of max L, R plus root's data and root's data. Since L and R are both 0, max single variable will be 3. We take another variable max top, which will store the max of max single and L plus R plus root data. So max top will be 3. Now variable res will store the max of res and max top, so res will be equal to 3. We return max single and finish execution for node 3. Execution for node 8 is resumed and now we pass the right child of 8, which is 5. Again, as root is not null, we pass the left child of 5, which is null. Since root is pointing to null, we return 0. Now we pass the right child of 5, which is also null. Again, as root is null, we return 0. Now we take max single variable and since both R and L are 0, max single will have value equal to root's data. Max top will store the max of max single and L plus R plus root's data. So max top will also be 5. Now variable res will store the maximum of res and max top. So res will be equal to 5. We return max single and finish execution for node 5. Execution for node 8 is resumed. Max single variable will store the max of max L, R, which is 5 plus 8 or 8. So 5 plus 8, which is 13, is greater. Max top will store the max of max single and L plus R plus root's data. So max top will be 16. Now res will store the max of res and max top. So res will now be 16. We return max single and finish execution for node 8. Now we pass the right child of 10, which is 2. Again, as root is not null, we further pass the left child of 2, which is null. As root is pointing to null, we return 0. Now we pass the right child of 2, which is also null. Again, as root is pointing to null, we return 0. Now max single will be 2 as L and R are both 0. Max top will also be 2. Res will remain same as 16 is greater than max top. We return max single and finish execution for node 2. Now max single will be 13 plus 10, that is L plus root's data. Also max top will be L plus R plus root's data, which is 25. Since max top is greater than res will now be 25. So 25 is the maximum path sum in this binary tree. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.